Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'm going to talk at you about some automotive stuff today. Thank you so much for tuning in. I really appreciate everybody that listens to the show. Before we jump into the show, I just want to remind everyone, if you're looking for any top-down equipment that includes scan tools, battery chargers, thermal imagers, jump packs, programming equipment, including some EEPROM stuff that they've got now, hit me up. I am happy to get you pricing on stuff, get those tools ordered for you, and be your support on those tools. I can answer any questions you got. Just shoot me a message through Facebook or the email, which you'll find in the show notes for this episode, and we'll get you set up with some tooling. All right, with that out of the way, we'll jump into the episode here. You got just me today. I'm going to talk about one specific area of a specific type of vehicle that I run into a lot as a mobile diagnostic technician. So I get called into shops pretty frequently for this issue. And this is Dodge, Chrysler. I don't know if it covers Ram and Jeep, but definitely the Dodge and Chrysler vehicles, Mopar vehicles with the 62E automatic transmission. All right, I service a lot of transmission shops, so that may play a role into why I see so many of these, but you may see some of these in your shop. This isn't necessarily anything new, but the year range for these vehicles with these transmissions, and I'm going to go through the vehicles and what this covers and when this covers, but this is about 2007 was the earliest that I've seen this. And this goes all the way up to 15 and 16 is the newest I've seen it in some of the Caravans, although it could be even later than that. Just haven't seen them in shops yet. But it's a number of years. And lately it's really been around the 2010 to 12. I'm getting a lot of calls for these particular vehicles, right? Something that's 8 to 10 years old is now when it's going to be in the aftermarket independent service shop, and you're going to be seeing these failures in vehicles. So what this is this is circuit codes for the automatic transmission, specifically pertaining to the solenoids that operate this 62TE transmission. And this is used in a number of vehicles. So first thing I actually want to do, I gave you the year range. I want to give you the models that this is included in. And maybe you've seen some of these, but I've seen almost all of these with these types of faults. This can include Chrysler 200, Chrysler Pacifica, Chrysler Sebring, Chrysler Town & Country, of course the Dodge Grand Caravan, Dodge Avenger, Dodge Journey, the Promaster, and even everybody's favorite, the Volkswagen Routan, which is a Volkswagen that's really just a Dodge Caravan. Anyways, same thing. They're all using that 62E automatic transmission. It's got 6 speeds and 6 different control solenoids to operate it. What happens is circuit codes set for the solenoids that operate the automatic transmission. And these are going to be located within the transmission. It's underneath the cover on the front of the transmission. And I really haven't gotten a lot into the repair of these transmissions, pulling them apart or replacing solenoids or anything like that. But there's a big connector on the front of the, I guess you call it a side cover, but if you're standing in front of the vehicle on a transversely mounted engine, you're going to see the cover and the transmission connector at the front of the vehicle. They're going to be controlled by the powertrain control module. And the powertrain control module is going to set circuit faults for these solenoids inside the transmission that operate it. And once one of these circuit faults sets, let's say you have a P0760 or P0750, right? A couple of common ones that I've just recently dealt with, it's going to go into a limp mode. You're only going to have second gear. And this will be a hard fault. Usually, I have seen them be intermittent when they first start to fail, but eventually they become a hard fault. And this will happen as soon as you key up the vehicle. You don't even have to start it, and these circuit codes will set, which is a really good indicator that it's a circuit fault and not something mechanical. But it even says in the definition of the code that this is circuit related, so it's electrical. My ballpark, right? That's the sort of thing I'm easily able to confirm because I have some really good electrical testing methods that can prove these things out for me. So I like codes like that. I like hard faults, and I like circuit codes that are actually circuit codes and not mechanical. A lot of times I think a mechanical fault code for a transmission, relating maybe like a gear ratio or something like that, is a little bit more difficult to get an exact answer on what's wrong, right? Because I'm not a transmission builder, but I get asked a lot to diagnose these types of codes. I don't know all the different clutch packs and the arrangements of every single transmission that I work on. But when it's electrical circuit fault code, I can figure this stuff out. I can get you an exact answer. And this is one of those cases. But why am I talking about this particular application, these particular transmissions in these Chrysler vehicles? The difficulty becomes not so much assessing the circuit. It's really not that different than any other solenoid circuit. I should say the circuit itself is definitely not any different than any other solenoid circuit. What makes these challenging is the computer strategy involved with controlling and assessing the circuit and what the computer does if there's a fault. That will make these actually pretty challenging to diagnose if you're not aware of exactly what the computer is doing to activate the circuit and what it does once it sees a fault. But if you're aware of that stuff, there's a very easy way to test these. And that's really just what I want to share with you today. So if you run into any of those vehicles that I mentioned with this particular transmission, and I did want to throw in there too, the controller that's involved, the PCM, there are different variations of this. I've seen the NGC style controller with the big 4 connectors on the front. This is kind of the older version of Chrysler PCMs. I've seen the Continental version where it's got 2 big connectors on the top of the controller. And I've seen the GPEC, which is, again, 2 connectors, but they come in on, I guess, what you would call the side of the controller. That part of it doesn't really matter. All I'm really getting at there is this is not a specific PCM where this failure is being seen with these Chrysler vehicles. It's more to do with the transmission, and all of the PCMs that they use with this particular application seem to suffer from this. And we'll touch on why, or at least a speculation on why that is. But really, this is about the testing, right? So if you have one of these codes, you have one of these circuit codes for solenoid control in the 62E automatic transmission for a Chrysler vehicle that I mentioned, this is how you test it. So let's just go with a code. Let's say we have a P0760, which I just had the other day on a 2010 Dodge Journey, right? So this thing goes in the limp mode, code sets every time you key it up. The shop is wondering, do I have an issue with the transmission or a solenoid or a circuit or a PCM, right? It could be any one of those. And they got that from the code, that it's a circuit code, but where is the actual issue? What do we do to fix this thing? And how do I as a technician assess that? That's what we want to talk about, right? So first thing I want to go through is how the circuit is constructed. And this is important to understand if you're going to do an electrical diagnostic on this particular circuit, right? So we have a series of solenoids in the transmission. Generally, when you have one of these faults, you're just going to be dealing with one of these solenoids, and that's what we're going to focus on. So just imagine, because this is an audio-only podcast, just imagine in your head you have a single solenoid inside the transmission. This will be the OD solenoid for this particular code. But you have a single solenoid in the transmission. The resistance for these solenoids is about 1.5 to 2 ohms, depending on the temperature. But you have a solenoid in the transmission. Solenoid needs power and ground to function, right? And the PCM is going to be involved with that. One of the important things to understand about this circuit is that the TIPM, which is basically just the fuse box under the hood of these vehicles, the TIPM has a relay and it supplies power to all of the solenoids, right? So you'll have a yellow-red wire that comes from the TIPM into the connector for the transmission and the solenoid valve body, whatever you want to call that, solenoid pack, if you will. But the TIPM on a single wire provides power, or B+, to all of the solenoids inside of the transmission. And so this is also going to be a switch power, right? It's a relay. So it's going to be turned on and off depending on what's happening. And that is really important to understand because that will change with a fault in the system. But for now, relay in the TIPM providing power to all the solenoids, including the one that we're imagining in our head. And on the other side of that solenoid, there's going to be a wire that leaves the transmission and goes to the powertrain control module. Powertrain control module has a driver inside of it that's going to apply ground to that solenoid when it needs to activate it. All right, so simple enough circuit. And in most cases, a simple enough circuit to assess, right? We treat it like any other ground side switch circuit that we've dealt with. There's many of those on the vehicle. There's many of those that we've dealt with over the years in a number of different applications. A solenoid circuit is nothing new. It's pretty simple. It's not even pulse width modulated in this case. It's just an on or off outside of the torque converter. But those I don't see failures in electrically speaking. I've seen them stick physically, but I don't want to get off course here. Anyways, we're dealing with these circuit codes for these solenoids are going to be turned on and off. All right. So TIPM provides power to the solenoid. PCM provides ground to the solenoid. We get a circuit fault for our OD solenoid, which is located inside the transmission, and it will set as soon as we key up this vehicle. We don't even have to start the engine. We get this 760 code that pops back up. Now, we can go right to the diagnostic flow chart in the DTC information and take a look at what needs to be done for this code. And of course, it points out the fact that you're going to be assessing the power wire from the TIPM to the transmission connector. You'll be assessing the control wire from the PCM to the transmission. And if those check out okay, you're basically replacing the PCM at that point. Now, it has you go through some ohm checks, of course, checking short to ground, checking for an open, checking for a short to voltage, so on and so forth. I think there's a more efficient, I know there's a more efficient way to do this. That's what I've worked on because I've seen so many of these, is how can I assess these circuits quickly? And again, you might say, okay, well, this is just a solenoid circuit. We've done this before. What they don't point out in the DTC information is the strategy that the computer has once it sees one of these failures. And this is what I kind of wanted to point out. And then I'll go through my testing method to assess one of these circuits, right? Because our goal at this point is to determine, is the PCM correctly assessing a fault in this circuit, an open or a short somewhere, or is the PCM failed itself? Is it failure within the control module? How do we make that call? The strategy that's taken with the PCM and the whole vehicle can make this challenging. And here's why. So once a code is set for one of these circuits, there's a message that is sent out on the bus from the PCM to the TIPM, and it will shut down the power circuit to all of the solenoids in the transmission. And this is really just a fail-safe, easy way to get the transmission into a limp mode, right? If we kill power to all the solenoids in the transmission pack, we're going to go into default second gear. There's not going to be any shifting. You're not going to be able to drive very fast, but that's the default setting, is cut power to all of the solenoids. And I've actually found out the bidirectional controls for the solenoids are cut as well once one of these codes is set. And this isn't the first time that I've run into a scenario where a code set in a Chrysler PCM of this era makes diagnosing the circuit kind of challenging because you lose a lot of the functionality through the PCM and other modules, in this case, the TIPM. So getting the circuit to do what you want it to do is difficult because the PCM goes into a fail-safe state, right? It gets this code, it shuts down power to the solenoids, it shuts down the driver circuit itself, even if you're trying to use a bidirectional control. Of course, normal operation, this driver is not going to be activated once it sees the circuit code, and everything kind of just locks down on you. And that's where I have found that technicians have a difficult time with this, is that the whole system, the whole thing's kind of shut down once this circuit code happens. So what we need to do is figure out a way, again, to assess everything that's going on, even though the computer is going to go into a failsafe. And so this is my method of how I do this. First thing I'm going to do is find the control wire for the solenoid that I'm dealing with. So find a diagram, find a pinout for your PCM, find the control wire. So this would be the ground side of the solenoid that's controlled by the PCM, and you're going to back probe at the PCM. So at the PCM, control wire for the solenoid you're dealing with, you're going to back probe and you're going to connect a test light, and you're going to connect that test light to a ground on the other side. And then what you're going to do is you're going to cycle the key from an off position to an on position. And this is important that you cycle the key. If you don't cycle the key and the code is already set, you're not going to see anything on your test light. What you're looking for from this test light is that the test light lights up right after you cycle the key to the on position. Now, if a code is set or setting on this vehicle for one of the transmission solenoids, that light will go out shortly after you key it up. If there's no code set, that light is going to stay on. What this is proving to me is that, number one, the TIPM is powering up the circuit. And if I only have a single solenoid circuit and not others, I'm not too concerned about this, but I still want to verify that the TIPM is sending power. And not only that, this does a few things for me. It verifies that that power source is present, but it also verifies that the circuit is at least complete all the way from that relay in the TIPM down the yellow-red wire that goes through the transmission, through the solenoid in question, and back up through the control wire all the way to the PCM, right? Remember, I had a grounded test light, and if it lit up, that means that B plus made it all the way through the circuit, through the solenoid, and lit up my test light. Now, the solenoid and the test light are now in series to a ground path that I provided by the other end of the test light, but that's all there. Now, that doesn't mean that circuit is perfect, but it at least means I don't have an open, right? And, we talk about this all the time. One test is better than the other, and don't use an ohmmeter, whatever. Okay, that's fine. I'm all about doing multiple tests to prove the same thing. Like, if I have a suspicion on a circuit, I'm going to use multiple tests to prove out what's going on. And that's, again, what I'm going to do here, but this is my first check just to make sure that the power is turning on and it can make it all the way to that PCM, right? Now, this is kind of where I want to think a little bit about the PCM strategy too. And I did have to think about this a little bit when I was making the notes for this episode, because if power is making it all the way to that transmission through the solenoid and then all the way to the PCM in a key up state, and the computer is setting a code at this point, which it is, this code will set as soon as you key up the vehicle. You can clear it in the PCM, turn the ignition off, turn the ignition on, give it 20 seconds maybe. It's going to set this code again. You don't even have to start the engine. You don't have to put it into gear. It'll set the circuit code again. So at this point, I'm thinking, well, what is the PCM looking at and why is it setting this code? I'm clearly getting power right up to the back probed control wire at the PCM. And isn't that what the PCM should be looking for? And I think it is. Me personally, I think that is what is happening, is that it is looking for power on that circuit. So at this point, are we done? Is that it? Does that mean the PCM has failed? No, we definitely got to look a little bit closer. We got to do a few more tests just to confirm everything. But I did look into the DTC information because this got me thinking, again, what is the PCM looking for to set this circuit code? Now, in the DTC information, I don't know if it's 100% complete or accurate. I'm guessing incomplete is probably what it is. It says something about looking at an inductive kick from the solenoid. And if it doesn't see that, it's going to set this circuit code. But it also mentions that it will do periodic circuit integrity tests. I'm thinking at a key up position, when you turn that key to the on position, the TIPM provides power to that circuit. It is going to do a circuit verification test to see, am I getting power to the PCM through the solenoid when the driver is not being commanded on, right? Because in a key up situation, there's no reason to turn that driver on. There's no reason to turn that solenoid on. And I verified that that doesn't happen. Even in a good situation, the computer during a key up situation is not turning these solenoids on. But it is looking for voltage to that point at that PCM all the way through the circuit. And we've seen this on other control circuits as well. Fuel injectors being a really common example. They'll set a 200 code if it doesn't see power on the control wire when the control wire is not being turned on, because you should have voltage all the way up to the point of an open on a circuit if there's no voltage drop, right? And without the driver being closed, without ground being provided to the load, we will have voltage all the way up there. And the computer has sensing abilities. So again, this comes back to, well, if I have voltage there on my control wire, when I key this thing up, then am I done here? Is that it? Here's the other part of it that I would suggest that you do. And this is not only just to confirm that the rest of the circuit is intact and functional, but also that you don't have a solenoid that has taken out the transmission because it is faulty. And what we're going to do here is measure the amperage going through the circuit. Now, you can ohm check these circuits, which actually would take you more time. And that's what the DTC strategy has you do, is to ohm check the circuit. One wire, the other wire, the solenoid. Okay, that's great. And you should have 1.7 to 2 ohms. And that's good to know that value, because you can use Ohm's law to correlate it to an amperage value, but the ohm checking itself, for a number of reasons, is not the best method. If you want to use that in addition to everything else that you do to have an extra confirmation of the circuit, sure, go for it. But you would have to find the power wire on the TIPM side, find the control wire, ohm check it out that way, and you're not really loading the circuit. What I suggest you do here, since you're already back probed at the PCM on the control wire, and your test light has lit up when you cycled the key. If it didn't light up, then you need to go after that. But it should light up. And if the code's set, it's going to turn that light off quickly. And I don't know if I mentioned that or not. But if the code sets, you'll see that light come on the test light at that control wire, and then it will turn off several seconds after. And this isn't an ASD relay type of thing. This is because the fault is present in the PCM. If the fault is not present in the PCM, if there's no solenoid circuit codes, that light will stay on. The relay in the TIPM to supply the power to the solenoids will stay on as long as you have the key on. And then you start the vehicle and it should still stay on. And it should have power ready at all of the solenoids, and then the PCM can ground them at the time of its choosing, but that power should always be present, and it should always be present up to the control wire until that circuit's closed to ground. Okay. But anyways, that will depend on whether you have a fault or not. If you're testing these, you probably have a fault. So you'll see the light come on and then you'll see it turn off. But once again, you're right there. You're back probed at the PCM. So you've made one test so far. What you're going to do at this point is, at your back probe, you're going to take another wire, and you can fuse this if you want. I've fused jumper wires. But you're going to jump this to ground, and you're going to jump it straight to ground. That's where you want to be. You want to have a direct ground path to this control wire. What are we doing here? We're being the PCM. We're going to ground the control side of the circuit. Normally what the PCM does, this is the PCM's job, is to ground the circuit when the solenoid is going to be commanded on. And that jumper wire that you run to ground, you're going to put an amp clamp around it. You're going to cycle the key, and you're going to see, again, that the voltage will turn on, or maybe you won't see it at this point, but the voltage will turn on to that solenoid, and now you're providing a ground on the other side. You should have current flowing through that circuit, and it should equal somewhere between 6 and 7 for this solenoid. That's the correct amperage value for a solenoid in these transmissions that's not shorted out. Now, that's a lot, I think, for a solenoid circuit, 6 to 7 amps, and I have a feeling that's why these drivers burn out after some time, even if the solenoids aren't shorted. Now, you can do some assessment with an amp clamp, looking at the current ramp for these solenoids. You can also stress these solenoids, leave them on for a period of time, heat them up, and make sure that they're not shorted in a heated up position. I haven't seen that yet personally, but if you really wanted to be thorough, you could do that. Because the one question here would be, let's say we find a driver shorted in the PCM or failed in the PCM. Is it the solenoid that took it out because the solenoid's drawing too much amperage? And that's a possibility. I haven't run into that personally myself yet. I think just the normal amperage draw for these solenoids at 6 to 7 amps wears out these drivers over time, and they eventually burn out in these PCMs. But that's just speculation on my part based on what I've seen as far as failures go in these vehicles. But anyways, you've got a ground path that jumped to ground. You're measuring the amperage. You should see 6 to 7 amps when that computer, the TIPM, turns on power to the solenoid. You've provided a ground. You've got the proper amperage. That way you know the circuit is complete. It can handle a load. The solenoid's drawing the correct amperage. The TIPM is providing the power. And you're back probed at the PCM, right? So as long as the pin fitment and connector is good, you're kind of done at this point. The fault is within the PCM, the driver circuit. Now, someone might say, why don't you just use the bidirectional controls on the scan tool to see what happens there? Well, a couple reasons why that doesn't necessarily work in this case, because you can go into the active test of the PCM and you can command the solenoid circuits on and off, right? Well, in this case, if the driver actually was failed, you wouldn't see that amperage jump up on that circuit. You wouldn't see the computer ground that circuit because it's failed. But I've also found this. Once one of these circuit codes set, I am unable to run the bidirectional controls for any of the solenoids in the PCM. It shuts down the whole operation once it sees the circuit fault in this system. And so your PCM functions in that case become kind of useless for this test. Really, what I want to do here is just verify, okay, that I'm getting power up to that PCM. If I ground it at that point, I get the correct amperage. It's the PCM that's at fault here. And you can cycle the key several times and get the same result over and over again. And of course, you can check your powers and grounds to the PCM. But with this particular fault, when you run into these, as long as you don't have other circuit codes that are present within the PCM, you're pretty much going to replace the PCM to fix this. Now, as far as repair goes for these PCMs, because I've considered that, I've gone in, and the amount of effort that it takes to fix these does not appear to be worth the cost of a used PCM. They're extremely inexpensive to get used PCMs. For this era of Chrysler, used PCMs are completely doable, depending on the tooling that you have. But if you have an Autel and some programming equipment for Chrysler, you can make this happen fairly easy on one of these vehicles. So I haven't gotten into any of the repair. What I did want to note on this that I did find pretty interesting is that the drivers for these solenoids are not your typical transistor, right? You think of a transistor as 3 connections. If it's a MOSFET, it's a gate source and a drain, right? That's not what you're going to find in these. In one of the GPEC controllers, which is a newer Dodge Caravan, I ohmed out the circuit within the PCM just to see, okay, where's this driver? And it actually had 9 legs on it, 8 small legs, and then 1 big connection to send the current for the solenoid. So there's more going on in these drivers than just an on-off transistor. I think, and I don't know this for sure, I tried looking up some data sheets and I'm not 100%, but I think some of the voltage measurement, the assessment for that circuit to see if power is reaching the PCM is done within the driver. And when the driver fails, it's unable to tell whether or not the voltage reached the PCM, right? When we key it up, the TIPM powers up the circuit. It goes all the way through up to the PCM. And now it's the PCM's job to say, yep, power is here, the circuit's good. And I think that's done within the driver of these circuits. Again, not 100% sure on that, but the fact that there's 9 legs on this driver for this transmission solenoid makes me think that there's a little bit more going on in this chip than just on and off. Anyways, I haven't actually repaired any of these. I think it would definitely be possible. I know it would be possible. It's just whether it's worth the effort or not. The last thing that I wanted to mention on replacement of these PCMs is to really pay attention to the part number on the PCM itself for replacement. And there can be a hardware part number on a sticker. There can also be what they call ECU or PCM part number, which actually correlates to the calibration file that's within that PCM. If you get the wrong calibration file, you have to match the hardware file. But if you get the wrong calibration file for these, it will work, right? The junkyard will sell it to you, say, yeah, it fits our parts crossover, and it'll definitely bolt up and plug in, but you can get some weird codes. You can get some communication codes for ABS, for traction control, for all-wheel drive, for circuits that don't exist on that car. And through conventional programming, you're unable to fix this, right? You can match the immobilizer, which is one of the parts that you have to do for these Chrysler computers if you're doing used. Or new, I guess, but for used is really what I'm talking about here. You match the immobilizer, but if the calibration is wrong, that calibration file, you're not going to be able to fix that with conventional programming means. And you'll end up with some other codes that weren't there before, but now exist. And maybe your customer's okay with that. They're like, okay, whatever. So use DCM, my light's on. I don't care. But maybe they're not. There are ways to fix this. But the first thing that you need to know is whether or not the ECM that you've gotten is going to work for the vehicle. Now, if you look at the calibration file, there's a series of numbers and there'll be 2 letters on the end of this either sticker that's on the side of the module, or you can plug it in. You can get it through the scan tool. But there'll be a series of numbers. It'll be 06806, whatever. The first part, if it's going to even bolt up and plug into the vehicle, a lot of times that part of the number is the same, and it should be the same. You usually won't have problems here. Where the problem is the last 3 numbers of this part number, this calibration file, which again is stamped on a sticker on the side of this thing in a lot of cases, those need to be matched, right? So let's say it's a 244 AD, just as an example. The letters, they don't so much match because that can be corrected even with traditional programming methods. But the last 3 numbers, they are critical for it to be right for the vehicle that you're putting it into. Okay, and so this may be something like this thing has ABS, or this thing has all-wheel drive, or this thing has 2 fuel senders, so for the level for the fuel tank. And there's an endless number of different possibilities for these things. And there's a whole bunch of different possibilities, even for just one vehicle. You can have federal, you can have California, you can have ABS, not ABS, all-wheel drive, all kinds of different things where one module plug into a bunch of different cars, and the junkyard's going to tell you, yep, this fits, and it does fit, and it does plug in, and you can even get it to run, but you're going to get codes. Again, the last 3 numbers, so if it ended with 244 AD, the 244 is the one that you want to match with that used part, okay? Now, let's say you already got this module in and it doesn't work. What do you do? Or maybe you can't find the one that you're looking for. There is ways to fix this, but it involves some specialty programming to do this, stuff that is beyond the OE level. Not something that I'm going to get into on this episode, but what I want to at least offer to anybody is if you'd like to reach out, I can definitely help you out with this, whether it be instruction on what tooling to get, or you can even just send me the module and I can correct it for you. I can make this module work for your application. Now, this is bearing that the hardware is correct, and there's some hardware checks that you can do. Again, with the there is a Chrysler flash file reference, which I'm actually going to put in the link of the show notes here, that you can use and use some Control F magic to figure out real quick, okay, what hardware is going to work for my application. And in a lot of cases, you can figure out exactly what flash file you need. And you can use the flash file that's present in the controller you have to see, is it going to work with the car that I'm trying to put it in? It's a really, really useful document. And if you can find it, the PDF with some Control F, you can figure this stuff out really quickly. And if you're doing used Chrysler modules around this era, it is super, super handy. I might make a video on that at some point because it is one of the more useful tools that I have for dealing with Chrysler applications. But I'll put a link in the show notes for it at least. Go check it out. Download it on your computer. They do update it, so I would definitely recommend accessing this through the site as opposed to just using a downloading document, because it will be updated from time to time. But you can figure out this stuff as far as what computer goes in what car and what's going to work where very, very quickly. But again, let's say you got the wrong one in there. Chrysler Scan Tool isn't helping you out. You're stuck with codes. Give me a ring, shoot me a message through Facebook or email, and I'm happy to help you out with that one way or another. We'll see if we can resolve it and see if we can make it happen for you. But anyways, that's all I got on these transmissions. And the reason I want to talk about it is because I run into it so often at shops. And it's just the computer strategy, right? That the computer shuts down power from the TIPM and that it will stop bidirectional controls. And that if you have things unplugged on this thing, it just completely shuts down operation of this transmission. I think that's really the big reason why this is so difficult for technicians. But why I want to talk about it is back probing with a test light and an amp clamp. And you can assess this circuit within 10 minutes. You can be done and say, yeah, it needs PCM. Let's move on with our day. And then you get into the programming side of it. But pretty easy once you understand what it's doing. And hopefully I've been able to help you out with that today. But just like to say thank you to everybody for listening. I really appreciate it. If you're interested on being on the show as a guest, hit me up. I'll be happy to have you. Anybody that wants to talk about the industry and is passionate about automotive world, I'd love to have you on. We'll have a great talk. Other than that, let's all get out there and start fixing the world one car at a time.